everyone, my name is Kirti. I have already posted a video on theory portion of enzyme substrate catalysis. So that video is of nearly 45 minutes, but in that 45 minutes we have covered the entire thing, like we have covered the derivation of the rate equation for enzyme substrate catalysis. We have covered the different types of linear and non-linear plots like Lineweaver-Burke plot and Adie-Hofstee plot. I have also taught what is catalytic efficiency, what is turnover number, the significance of Michaelis constant. So all this theory portion is covered in that video. In this video, we are going to solve about 7 questions on this enzyme substrate kinetics. Okay, so this will be very helpful for your CSIR-NET exam and GATE exam as well. So the question here is, you can do one thing, you can pause the video and you can try to solve the question by yourself. If you are not able to solve, you can play the video. Okay, the question is in rate inverse versus substrate inverse plot for an enzyme catalyzed reaction following Michaelis Menten mechanism. The y-intercept is 5000 molar inverse second inverse. If the initial concentration of enzyme is 10 power minus 9 molar, calculate the turnover number. So here we are given that the enzyme substrate kinetics follow Michaelis Menten mechanism. So we can use the rate equation of Michaelis Menten mechanism. So the rate equation is given by V. So V represents the rate here. V is equal to V max into concentration of substrate by Km plus S. So here Km is Michaelis constant. So what is the data given here? It is said that the graph is between rate inverse versus substrate concentration inverse. So the graph is between rate inverse is 1 by V. Substrate concentration inverse is 1 by S. So now we have to draw a plot between 1 by V versus 1 by S, and this plot is Lineweaver-Burke plot. So this has been already discussed in previous video. So if you do not have the idea, I will give the link in the description. So this is Lineweaver-Burke plot, the plot between 1 by V versus 1 by S. Now how do we obtain this plot? Now I can write this equation in the form of 1 over V. For that I need to inverse this equation. So after inversing, I will get 1 by V is equal to Km plus S by V max into S. So I can write it as 1 by V is equal to Km by V max into S plus S by V max into S. Now I can cancel the substrate concentration here. So this term becomes 1 by V max. Okay, this will be 1 over V max. Now here I can write Km by V max into 1 by V max. Now this equation is of the form y is equal to mx plus c. So here y is 1 by v, x is 1 by s, and the slope is Km by, so what is the slope here? Km by V max. And this is the y-intercept. What is the y-intercept here? C is the y-intercept, which is 1 by V max. So now let us look at the question. What is the data given? So you are given the y-intercept, that is 5000 molar inverse second. So the value of intercept is, so here the intercept is 1 over V max. That means the value of V max is 5000 molar inverse second. And you are also given the initial concentration of the enzyme, that is E0. So what is the value of E0? 1 into 10 power minus 9 molar. So now you are asked to calculate turnover number. So I already told you in the previous video that turnover number is defined by K2. Okay. So here Vmax can also be written as K2 into E0. Okay, this is the formula for Vmax and its derivation is given in the previous video. So now we have intercept value. From intercept value we can easily get Vmax. So Vmax will become 1 by intercept. So if I is 1 by Vmax, Vmax will be 1 by I. So I can calculate Vmax as 1 by I. So what is the value of I? 5000. So 1 by 5000 molar inverse second. So what does this become? 1 over 5000? It becomes 0.2 into 10 power minus 3. Okay. Here if the unit goes in the numerator, it becomes molar second inverse. So molar second inverse. So this is the value of Vmax. But we know that Vmax is K2 into E0. So instead of Vmax, I can write here K2 into E0. So what will be K2? K2 can be this by this Vmax by E0. If I divide on both sides with E0, I will get the value of K2. Or I can take this E0 on the right hand side to get the value of K2. So K2 will be this Vmax by E0. So 0.2 into 10 power minus 3 molar second inverse. So what is the value of E0? Here 1 into 10 power minus 9 molar. So here we can cancel this molar, then we will be left with the unit of second inverse. So the unit of K2 is always time inverse. Here it is second inverse. Okay. So we will get K2 as 0.2. When this goes into the numerator side, we will get 0.2 into 10 power 6 second inverse. So what is K2? K2 is the turnover number. That means in 1 second, one enzyme is converting 0.2 into 10 power 6 substrate molecules into products. Okay. So here is how you solve this first question. Now we move to the second question. So let us do the second question now. So what does the question say? For an enzyme catalyzed reaction, a Lineweaver-Burke plot gave the following data. So we know what is Lineweaver-Burke plot. It is the plot between 1 by rate versus 1 by substrate concentration. So here the slope is given, which is 40 seconds, and intercept is also given, and we are okay. Initial concentration of enzyme is also given, and we are asked to find out the catalytic efficiency. So what is catalytic efficiency? Catalytic efficiency is defined as catalytic efficiency is K2 over Km. So turnover number by Michaelis Menten or Michaelis constant gives you catalytic efficiency. So now we have to find the value of this term K2 over Km. So to find out K2 over Km, we need both K2 and Km. So how do we find K2 and Km from this Lineweaver-Burke plot, from the slope and the intercept? So here you are given the slope value. What is the slope? Km by Vmax. So the slope is Km by Vmax, which is 40 seconds. Here we do not have the value of Vmax, so we cannot find Km. But from the intercept, so you are also given the intercept value. So intercept is 1 by Vmax. So from here we can find the Vmax value, and we can put it in this equation to get Km. So intercept is 4 mole per decimeter second inverse whole inverse. Okay. So how do I get Vmax? I get Vmax by inverting this. I get Vmax by doing 1 by intercept. So if I do 1 by intercept, I get Vmax, which will be equal to 1 by 4 mole decimeter inverse second inverse whole inverse. Okay. So Vmax will be equal to, what is 1 by 4? It will be 0.25. When this entire term goes to the upside, this inverse get cancelled. Okay. So there will be no inverse. So what will you get? Mole decimeter cube minus 3 second inverse. Now you have the value of Vmax. From here directly you can get K2, because we know that Vmax is K2 into E0. So do you have the initial concentration of enzyme in this question? Yes. E0 value is already given. So if you substitute E0 here, so if you do Vmax by E0, you will get the value of K2. So I will do Vmax by E0, which is 0.25 mole dm power minus 3 second inverse by initial concentration of enzyme is 2.5 into 10 power minus 9 mole per decimeter cube. So here, so this will be K2. Okay. So here you can cancel mole decimeter per decimeter cube. So this unit gets cancelled. Now the unit that is left is second inverse, and we know that the unit of K2, that is turnover number, is second inverse. So what can I do here? I can multiply both numerator and denominator with 10. So here I'll get 2.5 by 2.5. So that gets cancelled. Here if I multiply, okay, I'm doing into 10 in the numerator and into 10 in the denominator. So it becomes 2.5. So this will get cancelled by this. Now what you are left with is 10 power minus 8. 10 into 10 power minus 9 is 10 power minus 8 in the denominator. So you will have the unit of second inverse. So when this 10 power minus 8 goes up, it becomes 10 power 8 second inverse. So the value of K2 is 10 power 8 second inverse, and value of Km is not yet found. Okay. Okay, to find Km, we need to have Vmax, and we already have Vmax as 0.25 mole decimeter per decimeter cube per second inverse. So I will note down the value of K2 here, which is 10 power 8 second inverse. Now we have to get the value of Km. So we can find the value of Km from this slope. So how can I get the value of Km from slope? If I do slope into Vmax, I will get the value of Km. So Km will be slope into Vmax. Now what is the slope here? 40 seconds. Into what is Vmax? 0.25 mole dm power minus 3 second inverse. So here the unit of second gets cancelled. Now what you have? 40 into 0.25, that is, I think that is 10. So 10 mole per decimeter cube. So this is the unit of concentration, that is molar. Okay. So the unit of concentration is, so the unit of Km is the unit of concentration. Now we have the value of Km. We also have the value of K2. So you can get the catalytic efficiency by doing K2 over Km. Now we find the catalytic efficiency, that is K2 over Km. I will rub this part. I'll do it here. Catalytic efficiency, that is K2 over Km, is equal to, Km is this much. What was K2? 10 power 8 second inverse. So K2 over Km is, so when this goes to upside, it becomes 10 power 7. So 10 power 7 mole inverse decimeter cube. So this is the value of catalytic efficiency, 10 power 7 mole inverse decimeter cube. Sorry, this unit second inverse is missing here. So it becomes 10 power 7 mole inverse decimeter cube and second inverse. Okay. So this is the value for catalytic efficiency. Let us solve this third question. So this question says, in the Michaelis Menten mechanism for enzyme kinetics, the expression obtained is, so this is the expression given, and from this expression you have to calculate K2 and Kn. So K2 is the turnover number, Kn is the Michaelis constant. So we know the rate equation for this enzyme substrate kinetics, that is V is equal to V max into S over Km plus S. So you have to convert this equation into this form. So how do we do that? On the left hand side you see that there is V over E naught into S. So how do I get this E naught? We know that V max is K2 into initial concentration of the enzyme. So I'll remove this V max and write it as K2 into E naught. Okay. So this becomes K2 into E naught. Now I can bring this E naught and S on the left hand side. So it becomes V over E naught into S. So the left hand side matches here. Okay. Now let us see what is the right hand side. Right hand side is K2 by Km plus S. Okay. Does the right hand side match here? No, because here you see there is a term V on the right hand side and here there is no V. So still we have to modify this. So what we can do is, okay, we'll do one thing. Yeah, we'll keep this E naught and S here. So I'll take this term on the left hand side. So it becomes V into Kn plus S by E naught into S. So here I will have only K2. So I'll multiply this V with the terms inside this. So I will get V into Km plus V into S by E naught into S. So that will be equal to K2. So now what can we do? We can split these two terms and we can write them as V into Km by E naught into S plus V into S by E naught into S is equal to K2. So I can cancel the S term here. So I will be left with V by E naught. Okay. Okay, I can do one thing now. I can take this entire term on the right hand side. So I will continue that here. So Vkm by E naught into S is equal to K2 minus So I am taking this on the right hand side. So it becomes minus V over E naught. Okay, now we have V on this term. So what we can do now is, here there should be no Km, right? V by E naught into S. There is no Km. So I'll take this Km on the right hand side. So I will get V by E naught into S will be equal to K2 by Km minus V by Km, or you can write it as 1 by Km into E naught into V. Now you can compare this equation with this one. So we have V by E naught into S. So the left hand side matches. Right hand side K2 by Km. So this first term is a constant because K2 is also a constant and Km is also a constant. So here you have some constant into V by E naught. So we have V by E naught here. So V by E naught. The constant here is 1 over Km. So now when we compare this equation with this equation, we can clearly see that K2 by Km is 1.4 into 10 power minus 12. So K2 by Km is 1.4 into 10 power 12. 1 by Km is 10 power 4. So 1 by Km is equal to 10 power 4. So from here you can find the value of Km. So Km becomes 1 by 10 power 4, that is 10 power minus 4. I already told you that the unit of Km is the unit of concentration. So I will write here molar. Okay. So this is Km is 10 power 4 molar. Now I have K2 by Km. So from K2 by Km I can find the value of K2. So K2 by Km is this much. Then so I'll write it here. K2 by Km is 1.4 into 10 power 12. So K2 becomes 1.4 into 10 power 12 into Km. So what is Km? 10 power minus 4. So here I get 1.4 into 10 power 12 into 10 power minus 4. So what I get? 1.4 into 10 power 8. Okay. So the value of K2 is 1.4 into 10 power 8. Okay, we know that the value of, the unit of K2 is second inverse. So since there are no units given in this question, we can ourselves write as the value, the unit of Km as molar and the unit of K2 as second inverse. So this way you can solve this problem. Now let us move to the next problem. Let us see the fourth question now. So it says an enzymatic reaction proceeds with the rate which is half of its maximum rate at substrate concentration of 0.02 molar. Calculate Kn. So in question it is given that the rate is half of maximum rate. So if maximum rate is Vmax, then the rate is Vmax by 2, and at this rate the concentration of the substrate is 0.02 molar. We know that the rate equation is V is equal to Vmax into S by Km plus S. So now when we have to find out when this rate becomes Vmax by 2. Okay. Suppose if I take the Km value equal to the concentration of substrate. Suppose if Km is equal to S, then what will we get? V is equal to Vmax into S by S into S. So S plus S. So that becomes 2s. So I can write here as 2 into s. So now I can cancel this substrate concentration. So the rate becomes Vmax by 2. That is half of the maximum rate. So we see that the rate becomes the half of maximum rate when the concentration of substrate becomes equal to the Michaelis constant. So here you are said that the enzyme reaction proceeds with the rate which is half of its maximum rate, and at that rate the substrate concentration is given. So you are asked to find out the value of Km, that is Michaelis constant. So at Vmax by 2, Km is equal to S. So if S is 0.02 molar, then Km will also be equal to 0.02 molar. Okay. So this concept we have already seen in the theory portion. So question in this way can be asked from that topic. Okay. So now we move to the next question. So the fifth question says the rate of an enzymatic reaction is 2 into 10 power minus 5 mole per liter per second at 0.01 molar concentration of the substrate. So this is substrate concentration. Okay. So what is the maximum rate of the reaction? So the Km value is also given. So what we are given? We are given the rate of the reaction, that is V, which is 2 into 10 power minus 5 mole liter inverse second inverse. We are given the concentration of the substrate at which the rate is 2 into 10 power minus 5. So that concentration is 0.01 molar. Molar is nothing but moles per liter. Okay. Molar is moles per liter. Molar or moles per liter. What is the maximum rate? Now you are asked to find Vmax. So we know the rate equation for this enzymatic reactions are V is equal to Vmax into concentration of substrate by Km plus substrate concentration. So from this you have the value of V. You also have the value of Km from here. You have the substrate concentration. So you need to find Vmax. So I'll keep this Vmax here. I'll take this entire terms on the left hand side. So I'll get Vmax is equal to V into Km plus S by S. Okay. So from this we can get Vmax. So we have the value of V, that is 2 into 10 power minus 5 moles per liter per second. And you also have Km value which is 0.02. So this is 0.02 plus what is the concentration of substrate? 0.01 plus 0.01. So the unit of Km is also molar and the concentration of substrate, unit of concentration of substrate is also molar. So I can write here outside the bracket this molar, and in the denominator you have substrate concentration, that is 0.01 molar. So from here I can cancel the unit of molar, and here 0.02 plus 0.01 gives you 0.03. So I can cancel this. So this becomes 3 times. Now what I have is 2 into 3, 6 into 10 power minus 5 mole liter inverse second inverse. So this is the value of maximum rate. So the maximum rate is 6 into 10 power minus 5 mole liter inverse second inverse. Now let us solve the question number 6. So the question says slope and intercept of V by S versus V plot. So this is the AB-Hofstee plot. Are minus 100 and 2 into 10 power 8 respectively. So slope and intercept are given. we are asked to find the value of Michaelis constant and turnover number, that is K2. So how do we get the graph of V by S versus V? We can get it by rearranging the rate equation. So what is the rate equation for enzyme substrate kinetics? It is V is equal to V max into concentration of substrate by Km plus S. So now I take this denominator to the left hand side. So what does it become? V into Km plus S is equal to V max into S. Now I multiply this V inside this bracket. Okay, so I get V into Km plus V into concentration of substrate is equal to V max into S. So now I can take this V into S on the right hand side to take this term S common. Okay, so what I get is V into Km is equal to V max into S minus V into S. Now I can take S common out of these terms. So I can write it as V max minus V into S. Okay. So what I have on the left hand side? I have V over S. So I'll take this S on the left hand side and I'll take this Km on the right hand side. So what I get? V over S is equal to V max by Km minus V by Km. So this equation is of the form Y is equal to, see, this is constant because V max is a constant and Km is a constant. Therefore, this is a constant minus M into X. So here X is V. Now we can draw a plot between V by S versus V. So what is the plot? The plot is a straight line equation with a negative slope. Okay. So the plot is straight line. V by S versus V is a straight line with a negative slope. So from here you can clearly see that this intercept value is V max over Km. So what is intercept? V max over Km. And what is the value of slope? Slope is negative, that is minus 1 over Km. Okay. So in this question you are given the value of slope and intercept and you are asked to find out the value of Michaelis constant and turnover number. So you can easily find out Michaelis constant from the slope. So the slope is given as minus 100. So slope is minus 100 and we know that slope is minus 1 over Km. So minus 1 over Km is minus 100. So that implies Km will be equal to, minus gets cancelled, 1 over 100. So that will be 10 power minus 2. Now we know that the unit for Km is concentration, that is molar. So now we have to find out the value of turnover number, that is K2. So how do we find K2? Let me drop this. So we know that K2 is equal to, we know V max is equal to K2 into E0, right? So we do not have the value of K2, but we can find V max from this intercept. So intercept is V max by Km. So V max is K2 into E0 by Km. Now from here I can find out K2. So if I take this in Km and E0 on the right hand side, I can write it as, I'll write it here. So K2 will be equal to I into Km by E0. So I into Km by initial concentration of the enzyme. So what is I value? Intercept value is given as 2 into 10 power 8. So I'll rub this. Okay, intercept is given as 2 into 10 power 8 into value of Km is 10 power minus 2 molar by, or we'll skip the units here because there are no units given in the question. So at the end we'll put the units. And the value of initial concentration of enzyme is 5 nanomolar. So that becomes 5 into 10 power minus 9. So, okay, 2 by 5 becomes 0.4 and here it becomes 10 power 6, 10 power 8 into 10 power minus 2 is 10 power 6. So when this 10 power minus 9 goes to the numerator, it becomes 10 power 6 plus 9, that is 10 power 15. Okay, and we know that the the unit of K2 is time inverse, that is second inverse. So first we found the value of Km from the slope, and from intercept we found the value of K2. We know that intercept is Vmax by Km, and we know the value of intercept. We know that Vmax is K2 into E0. So we know E0, we know Km, and we know intercept. So we found K2 by multiplying intercept into Km and dividing it with E0. Okay. So now we got the value of K2 as 0.4 into 10 power 15 second inverse and Km as 10 power minus 2 molar. So let us solve the seventh question. The question is, for an enzyme substrate system obeying Michaelis, this MM stands for Michaelis-Menten mechanism, the rate of the product of formation when the substrate concentration is very large as limiting value is 0.02 mole decimeter cube inverse and second inverse. So they have given the maximum rate. So they have clearly mentioned that the rate of formation when the substrate concentration is very large as limiting value. So limiting value must be the maximum rate. So in the previous class we have learned that rate versus concentration of substrate will be like this. So this graph will be like this. So they said at very large concentration of substrate concentration is very large. That means in here the rate becomes Vmax. Okay. So the rate becomes maximum at large concentration of substrate. So the value is given as, so okay, I'll write it here to save the place. So Vmax is given as 0.02 mole decimeter power minus 3 and second inverse. Okay. So at a substrate concentration of 250 milligram per decimeter cube, so they have given some substrate concentration which is 250 mg per decimeter cube. The rate is half of this value. That means at S equal to 250 milligram per decimeter cube, the rate will be Vmax by 2. Now what did they ask us to find? They asked us to calculate K1 over K minus 1, assuming that K2 is far less than K1. Okay, how do we get this K1 over K minus 1? So we know that at Vmax by 2, Km is equal to the concentration of substrate. So this we have seen already many times. When Km becomes equal to S, so I'll do it here. V is equal to, we have this rate equation, right? By Km plus S. Now when I substitute this Km with S, what do I get? So I get Vmax into S over 2S. So this S gets cancelled and V becomes Vmax over 2. So the rate value becomes half of the maximum rate when Michaelis-Menten constant is equal to the concentration of substrate. Now we are given the concentration of substrate, that means it is equal to Km, right? So at this concentration V is becoming Vmax by 2. So substrate concentration must be equal to the Michaelis constant. So what is Michaelis constant? We know that it is K minus 1 plus K2 by K1. Km is k minus 1 plus k2 over k1, which we have already seen in the theory class. So here they have asked us to assume that k2 is far less than k minus 1. So if k2 is far less than k minus 1, the value of k2 can be neglected. Okay. So in comparison with k minus 1, k2 is very small. So we can neglect k2. So this becomes k minus 1 over k1. So km is 250 milligrams. Okay. 250 milligrams per decimeter cube. So that value is equal to k minus 1 by k1. But what we want, we have to calculate k1 over k minus 1. So the inverse of this. So what will I do? I will invert this. k1 over k minus 1 is equal to 1 by 250 milligrams per decimeter cube. So how much is this? I can write it as 25 into 10. So 0.04 into 10 power minus 1. So that will be 0.004 milligrams into decimeter cube. So here the value of k1 over k minus 1 is 0. Is this right? 1 over 25 is 25 4s are 100. 0.004 into 0.004. Okay. Let me repeat it again because it is a bit tricky question. So you are given the maximum rate, which is Vmax. You have nothing to do with this maximum rate, and you are given other information saying that the rate is half of the maximum rate. The rate is half of the maximum rate when the concentration of substrate is 250 milligrams per decimeter cube. So V is Vmax by 2 when concentration of substrate is 250 milligrams per decimeter cube. But we know that V becomes equal to Vmax by 2 when Km becomes equal to S, V becomes equal to Vmax by 2. So Km will be 250 milligrams per second. 250 milligrams per decimeter cube. So Km we know it is k minus 1 plus k2 over k1, and here they have asked us to neglect this k2 value. Since k2 is far less than k minus 1, we can neglect it. So it becomes k minus 1 over k1. So, but what we want is k1 over k minus 1. We can get this by inverting it. So 1 by 250 is 0.004 milligrams per decimeter cube. So k1 by k minus 1 is 0.004 mg per decimeter cube. Thank you so much. See you in the next class. Bye-bye.